Welcome back to the Scotti-BYTE channel, and this is Scott. So one of the first things you'll find when you set up a new system is you have to have considerations on what your storage is and where that storage will be. And on some systems like Proxmox or Unraid or others, you have to make some advanced planning. And that's a good thing because you have to understand your infrastructure. And infrastructure is one of the things that I have always emphasized on the channel. So today I'm going to talk about LXD storage pools and volumes. And in the past I've covered LXD storage pools only to a very small extent, and I've covered volumes in as much as I've mentioned them in passing. But today I want to try kind of an overview. I'm not going to do a deep dive, but I am going to show you how you can use both storage pools and volumes, that is, additional storage pools and volumes. So in the LXD step-by-step video, which at this point, if you're not familiar with LXD, that would be the first video that you would try to watch, we performed a LXD init, which set up the default storage pool as part of the setup of the LXD system. So when you create containers, you're using the default profile, which uses storage in the default storage pool. And so I want to also emphasize that really there is no default storage pool. It's just that the storage pool is called default in LXD, and we tend to think since it's called the default storage pool, that's the default. But you can really use any storage pool that you want, and we're going to get into that and talk about how that is the case. The other thing is that by default, you're kind of used to the fact that when you enter a container, you're using device ETH0, and that's something else that's defined in the default profile, and we'll look at that as well. So new LXD containers are images that basically get copied from linuxcontainers.org to your default storage pool. And I'm thinking that now that Canonical has taken over the development of LXD, that may change in the future, but for right now, it still points to linuxcontainers.org. And we know that the new Incus container system will most definitely point to linuxcontainers.org because that's where it's going to be maintained. So LXD container data is stored in the storage pool that actually has the name default. And when you create LXD through doing the LXD init command, you have an option to change that. But I always emphasize to everyone that they should leave that the same because it allows you to think a little bit more organized about what you're actually doing. So LXD containers and LXD VMs can also create what are called custom volumes, and we're going to get into that as well. So in this tutorial, we're going to learn how to create additional storage pools as well as custom volumes and use them. Okay, sorry about the eye chart here, but this is what we're going to talk about today. In the upper left-hand corner, we have a copy of the LXD init command that we used in the LXD step-by-step video, and all I'm illustrating highlighted in red was when we created the default storage pool, which was actually a virtual ZFS file system inside of a file. And that's what we have here. As I depicted this disk sort of diagram, the default storage pool contains images, containers, LXD VMs, and custom volumes. And the default profile that is used for the default storage pool contains a definition of the Ethernet device, as well as the fact that there is root file storage, and this is disk storage, and it points to the default pool. So you can define additional pools that are created from empty disks on your systems, or they can be virtual disks that are mounted via loop devices. And I think I've got a couple of videos discussing how you can create virtual disks in Linux. And so you can create these pools for LXD using these types of file systems, including ZFS, BTRFS, or LVM. And I've also included teardown here, although it's not really a file system supported system. It's something that LXD has, which allows you to use just a file tree in the ordinary ext formatted directories as a file storage area. It's a little bit limited in its functionality, but I list it here nonetheless. So what we're going to be doing in our particular case in this tutorial is we're going to create a second virtual ZFS storage pool inside of a file, and we're going to call that file pool2.img, and we're going to create containers and a custom volume in the new storage pool. So the new storage pool looks pretty much just like the default storage pool. It would have images that are used to create containers. It would have containers. It would have LXD VMs potentially, and it can also have these new things that we're going to talk about called custom volumes that I have not really discussed at length before. I've alluded to them on the channel, but not talked a lot about them. So imagine that this storage pool is simply called pool 2. And likewise, we have to create a profile for it, and we'll call this profile pool 2. It has the same Ethernet device, uses the same LXD BR0, and it has the root path as well, but it uses its storage out of pool 2, which is disk storage, and of course we've named this pool 2. As you'll recall, we can list all the LXC containers we have on a LXD host by simply doing a LXC list command. And here you see that I have 5 LXD virtual machines, all of which are stopped, but I don't have any LXD containers, and we're going to fix that shortly. You can list all of the profiles you have on a given LXD host with the command LXC profile list, and here you notice that the third profile is the default profile. And so we can actually get in and take a look at it with a LXC profile edit default, and that will jump into the editor and take a look at that profile. And as we saw in the introduction, here we simply have a device called ETH0, and it's using the network LXD BR0 by default if we don't add another profile to it, which of course we've always been adding the bridge profile. And here it says that it uses the path of root on the default storage pool, and that is type disk. And then down here I have the list of all of the VMs, and all of them use the LXD default profile. In order to see our storage pools, we can do the command LXC storage list. And right now the only pool I have out here is the default storage pool, and it is a ZFS storage pool because I set it up with the LXD init command and selected the defaults as I did in the LXD step-by-step video. We can get an idea of what's stored inside of the default storage pool, and we can do that with the command LXC storage volume list default. And in this case, you can see that I have 4 images. It doesn't tell us what the images are because it doesn't have the description listed, and it has several virtual machines that are out here. It also lists snapshots because snapshots are stored in the storage pool. And then I have one custom image up here, or one custom volume, and that's what we're going to learn about today. Since we're going to create a virtual file to put our ZFS file pool into, I'm using the command truncate, and I'm setting up a 50 gigabyte file, which I'm putting in /home/scott/pool2.img, and that way it helps to document it a little bit. Now I use the zpool command to create the storage pool with a zpool create pool2, and I point to the file. We now tell LXD that we want to use that ZFS storage pool with the command LXC storage create pool2 ZFS source equals pool2. To verify that LXD knows about that storage pool, we can do the command sudo zpool list, and there you have the default storage pool that we created with LXD init, and we also have the pool2 storage pool here as well. Before we can begin creating any new containers inside of our pool2, we need to create a profile called pool2 where we'll include the directives for how to create containers that will be going inside of that pool. We have to go edit the profile that we just created, so we're going to do a LXC profile edit on pool2, and I made a copy of the information in the default pool, and we're going to make a modification to that information, which will be in the show notes. But basically, I'm going to have a device ETH0 just like in the default pool. Its network is going to be LXD BR0. It's of type NIC. We also have a root device. Its path is root /, but this time its storage comes out of a location called pool2, and the name of this profile likewise will be called pool2, just so that it helps document it a little bit better. We do a Control-O and hit enter to write out the changes to the file, and a Control-X to exit the nano editor. Now we can create a container inside of our new pool2 with the command LXC launch Ubuntu :22.04, and the name of the container will be container1, and then the name of the profile will be pool2, and that is what tells it where to put the container. I will also create a second container simply called container2, and it will be inside of the pool2 storage pool as well. If I perform a LXC list, you'll see all of the containers both in the default pool and also in pool2, but from looking at this description, there's no way that we can tell that container1 and container2 are in the pool2 pool. To get an idea of what is actually stored in pool2, I'm going to issue the command LXC storage volume list pool2. And here you can see that we have a container 1 and a container 2 in that storage, and we also have an image. This image is actually the Ubuntu 22.04 image that was used to create the container 1 and container 2. Next, I want to go ahead and create a volume, and this command LXC storage volume create pool2 volume 1 says create me a custom volume called volume 1 inside of pool2. And in fact, now if I turn around and do that same command LXC storage volume list pool2, you notice that volume 1 has been added to the list. Now that we have a custom volume, one of the interesting things we can do is to do a LXC storage volume attach from pool2 volume 1 to container 1, and then a mount point inside the container 1 called volume 1. So what this does is if we go in and say LXC shell on container 1, and then we do a df, you will note that there is a volume 1 mount point in here. If we cd over to /volume 1 and we do a touch on scott.txt and then do an ls, we have a file named scott.txt. Now if I exit back out to the LXD host, we can go ahead and create ourselves another attachment, and this time we'll attach pool2 volume 1 also to container 2. And now that it's attached to container 2, if I do a LXC shell over to container 2 and do a df, we also have the mount point volume 1. If I cd over to /volume 1 and do an ls, we have the scott.txt file. This means that two different LXD containers can actually point to the same storage. Now, no file locking is performed, so you have to be careful in terms of databases, but this might be a good way to share data between containers. I have brought up the LXD dashboard interface, and LXD dashboard is a GUI for LXD, which I've covered on the channel before, and I've got a video on how to install and configure LXD dashboard. I went down to my LXD host named Mondo. It says I have two containers running. There's container 1 and 2, and just like from the command line, we really can't see where these are running. However, we can go over to images and scroll down, and we also can't see where things are running. However, we can go over to profiles, and we can see that we have a pool 2 profile here, and we can go to storage pools, and storage pools list the default pool, and it also lists pool 2. If we go back to containers and we choose container 1, we can go over to devices and look at disk. And under disk, you notice that we have a volume 1, which has a path inside the container to /volume 1. To disassociate or to unmount volume 1, we have to exit back out of the container and go back to the LXD host, and we can issue the command LXD storage volume detach pool 2 volume 1 container 1. And likewise, we can do the same thing with LXD storage volume detach pool 2 volume 1 also from container 2. If we wanted to delete the storage pool, you have to recall that we still have the two containers running in it. So we have to do a LXD stop on container 1 and the LXD stop on container 2 as well. And then we're going to delete both those containers so that they don't take up space in pool 2. So we delete container 1 and we delete container 2. We also have to delete volume 1 because it's using space in the pool 2 storage pool. So we do LXD storage volume delete pool 2 volume 1, and that deletes that volume as well. Before you can delete a storage pool, you must delete everything using the storage pool. So just as a test, let's do a LXD storage volume list on pool 2. And it says that pool 2 is still being used by one item, and it is the image that we downloaded, the Ubuntu 2204 image. So now we have to do a LXD image delete, and we have to pick up this long name here. We'll copy it and we'll go ahead and put that in there. At this point, if we do a LXD storage list, you notice that pool 2 is still being used by one object, and the object it's being used by is that pool 2 profile. So we have to say LXD profile delete pool 2, and that'll get rid of that pool 2 profile. And if we do a list, you can now see it's used by 0 items, and it will be possible to delete that pool from our LXD host. In order to delete the pool from the host, we simply do a LXD storage delete pool 2, and it says the pool's been deleted. If I go back and do a LXD storage list, we only have the default pool, and you can see that pool 2 has been deleted. As a part of removing the pool from LXD, you can see that if we do a sudo zpool list, zpool does not think that there is a ZFS pool there, and all we have is the virtual file. So the final thing that we can do is we can do an RM on pool.img, and that will delete that file. Actually, it's called pool2. Let's get this right. And it deletes the file, and now that pool is completely gone, as well as its virtual file. So in summary, the default storage pool stores images, containers, LXD virtual machines, and custom volumes. We saw how you can create additional storage pools, and we created a virtual ZFS pool for our additional pool space, but you can also create dir pools, BTRFS, or LVN file systems for your additional pools in LXD. And we saw how to create custom volumes and associate them with containers. Anyway, that's it for today. Please subscribe and like to the channel, and don't forget to hit that notification bell, and we'll see you next time.